Nothing but a chemical in my head.
Oh, hi. I didn't see you there. Just reading my chemistry book cover to cover, like I do every weekend. Just reading about the periodic table of elements. You know about the periodic table of elements, don't you? You don't? Well, I conveniently have my laptop here, and hey, look at this. It's a little bit about the history. Why don't I take you into it? The periodic table is basically an arrangement of the chemical elements compiled by the respective chemical numbers in columns, called groups or families, and rows, called periods. The standardized version of the table we use now had started with a Russian named Dmitri Mendeleev, but there are other forms used, such as the extended periodic table, and a version formed by Charles Janet aligning the elements by their atomic energy levels, appropriately named the Janet periodic table. To find the origin of the periodic table, we're going to have to go back a few centuries. Since before the Middle Ages, basic elements such as silver, gold, lead, mercury, and tin have been well known due to their ease in excavation and discoverability in nature. But the first scientific discovery of an element occurred in 1649 when Hennig Brand discovered phosphorus. A bankrupt German merchant, Brand came across the element during his search for the Philosopher's Stone, a rock of folklore that was said to be able to turn relatively cheap metals into pure gold. Brand's research for the mystical stone led him on a wild goose chase throughout science, even going as far as to distill human urine. Ugh. Finally, in 1669, he came across a white glowing rock which he named phosphorus. He kept this discovery a secret, though, until a man by the name of Robert Boyle rediscovered the rock and made it public knowledge in 1680. Fast forward 100 years, and we find ourselves looking at the man who is considered to have created the first chemical textbook, chemist Antoine Laurent de Lavoisier. Lavoisier's textbook included substances that couldn't be broken down, such as mercury, zinc, hydrogen, oxygen, and nitrogen, and laid the groundwork for the modern list of elements. His lists also included light and caloric, which he believed to be material substances. Many did not accept Lavoisier's findings, though, as it only classified elements into metals and nonmetals. By the year 1809, we had a whopping 47 discovered elements, and it was becoming apparent that there were patterns in the way certain chemicals reacted, and scientists began to scheme up a way to classify them. Jumping ahead about a decade to 1817, Johann Dobryner found that the atomic weight of strontium fell midway between the weights of calcium and barium, all elements owning similar chemical properties. Come 1829, Dobryner proposed that the nature contained triads of elements, and that the middle element had properties that were an average of the other two members when ordered by the atomic weight. This he called the law of triads. Between 1829 and 1858, other scientists, such as Leopold Mellin, Ernst Lensen, Jean-Baptiste Dumas, J.P. Cook, and Max von Pettenkofer added on to Dobryner's findings and concluded that chemical relationships go beyond a triad and are much broader. It was difficult during this time to classify, though, as accurate values for each element weren't always available. Then comes 1862, a very important date when we are talking about the history of the periodic table of elements, because it's the date the first such table was published. The man who created it, Alexandre-Émile Baguerre de Chancourtois, was a French geologist and the first recorded person to notice the periodicity of the elements. The table, called the telluric helix, had a cylinder-like shape with the elements spiral staircasing down by increasing atomic weight, while de Chancourtois predicted the stoichiometry of several metal oxides. Some of his proposed elements were later found out to be ions and compounds. Moving on in time, we come to English chemist John Newlands, who in 1863 wrote a paper classifying the 56 known elements at the time into 11 groups and arranging them by similar physical properties. A year later, he proposed the law of octaves and published his own periodic table, aligned in a way that resembled the 7 intervals of the musical scale. Decades later, it was found by Gian Lewis in his 1916 article, The Molecule and the Atom, that another rule of 8, the octet rule, applies to the bonding of atoms, molecules, and electrons, and also shows a way to organize through valence shells.